Yeah, cool. Okay, so welcome everybody. My name is Lukasz Szydlo, and I'm a programmer with mostly Java background. Currently, I'm a trainer at But IT Solutions, but for the last 4 years, I was working for a customer as a consultant for one of the biggest real estate portal in the world. And this customer was very special for me because during those 4 years, it made for me tremendous transformation. 4 years ago, we started with one big monolithic application on which around more than 100 developers were simultaneously working on. So we can imagine how it was. And we were releasing once every quarter. Yeah? So once every 3 months, there was a release to production because of all the work and all the steps and all the testing and so on. And after 1.5 years, or maybe 2 years, we were able to still keep the original monolithic application, but decreased in size, which was deployed once per day. And lots of functionality we were able to extract to separate applications, which were deployed a couple of times a day by different teams, which had the responsibility for one or many applications. And this talk, this presentation, is a summary of what I have learned during this time about continuous delivery and continuous deployment. What is the impact of those techniques to how we work, how we develop software, and what process we need to go through to enable it in companies that currently do not have this kind of process. Okay, so first I would like to know the crowd. I will move a little bit here because here I can see something. I would like to ask you, how often do you deploy your application to production? Once a quarter? Hands up. No? Once per month? Hands up. Okay, some people. Once per week? Yeah, more than once per day. Okay, so actually a lot of people. That's actually good. And the second question is, how long does it take for you to run all the tests, prepare the build, and put it on production? Yeah? Over 15 minutes? Oh, a couple of people. Over or less than 15 minutes? Less than 5 minutes? Okay, one person. Okay. So hopefully there will be also something for you on this presentation, those who were fast and slow. Okay, and how many of you are doing something they can call agile? Yeah, we can say. Okay, so actually I think most of you. So if we start from this, the first of the 12 techniques of agile is this. Yeah? So we should have our highest priority should be to satisfy the customer for early and continuous delivery. Yeah? So if we are doing agile, then we should do some kind of continuous delivery. Yeah? But what does it even mean, continuous delivery? Yeah? It mean that we should, I don't know, deploy very often, or how often it should be? Yeah? It actually depends. There is no, I don't know, time limit or very strict definition. The only thing that matters in this is that the continuous delivery is a process that enables you to have as much automation and as straightforward process of delivering your software continuously. But continuously for one company can mean once per month, for other once per week, for other couple of times a day. Yeah? It doesn't really define it. Yeah? To start talking about continuous delivery, especially from a technical standpoint, what we should divide it into a couple of techniques that enable it. Yeah? And there are a couple of them. Yeah? Automated testing, continuous integration, continuous inspection, and continuous deployment. I will not talk about first three, because I think most of us or most of the companies already have those, but the continuous deployment. This is one that is, for me, the most interesting, and the one that is most controversial for a lot of people. Yeah? Why controversial? Because why we want to release our software a couple of times a day? Yeah? Where is the value in releasing this software so often? What can I do with one commit that is so valuable that it should go and be deployed on production? So to answer this question, we actually first need to establish some vocabulary. Release and deploy are two different things. They do not mean the same. Yeah? Release something is to, for at least how I am defining it, or how I will be using it during this presentation, releasing is the process of making feature available to the user. And deploying means putting the newest application version on production. This can have a totally different effect on our system. Yeah? If I put the newest version of my application on production, it doesn't mean that the new features that I'm working on are enabled, that the user can access them or can use them. Yeah? This is release. Yeah? So to answer my, or maybe to rephrase my previous question, why do we want to deploy, why do we want to release five times a day? We actually don't want to release 5 times a day. We want to release when something is ready. But we want to deploy 5 times a day. And we want to put the newest version of our application as often to production as it can be. But you may ask, okay, yeah, if we are not releasing, we are just deploying, so we are putting a dead code to production. Actually, yes. This is what I'm saying. Yeah? I'm saying that we should very often put the dead code to production and should not be responsible for releasing this stuff. Imagine the world in which you are not responsible as a developer or as a technical team for releasing the software. This is not your responsibility. You do not know when the software is ready from the business standpoint. Your product owner knows it. Yeah? The business people knows it. They've tested it. They said, OK, it is the right time. The campaign should start now, or something else should be started now. If they are the ones who knows when the particular feature should be enabled, then they are the ones that should decide it. And what we should do is to enable them to do it. Yeah? Imagine the world that your application has this dashboard. And every feature or every story that you are currently working on is a small toggle or a switch on this dashboard. And if the product owner decides that this particular feature is ready or not, he can just click this button on this dashboard, and on production, this feature just starts working. And if he decides that he's, OK, no, this feature is not working very well, then he just disables it. Yeah? And he can, for example, also enable this feature only for half of the user. Yeah? He can try to do with this new feature some kind of A/B test, even, to decide if this feature has the expected outcome or not. Yeah? But the question we should ask ourselves is, what's in it for me? Yeah? We just now described that the continuous delivery and this kind of giving the power of enabling features and putting them on production to the product owner makes sense, or for business people it makes sense. But what's in it for us? Yeah? How it will impact our work and our development? And I think the most important thing that was my or my team outcome was the peace of mind that we had. We had this process that every commit goes to production. Every commit. We are committing the stuff, and it just goes to production. And we don't have to care. We don't have to do anything. Yeah? The infrastructure is set up so that every commit goes to production if the tests are green. If the test failed, the application does not go to the production. But if the build is green, it does. It goes. It doesn't really matter. And if the bug comes, we don't have to, I don't know, wait to the next month and live with this pressure. Okay, application, there is a bug. If user will see it or not, if we will lose the money or not. No, if there is a bug, we just make a fix, commit, and the fix is on production. If it is a really critical bug, yeah, because we can say, yeah, bugs happen, but we have our release branches, and on those release branches we have tags, and on those tags we can do all kinds of stuff, and also pretty quickly react on the bugs on production, if they are there, even without this. Yes, but imagine that there is this kind of bug that is, I have to fix it for a week bug. It isn't the bug that will take me 5 minutes and it is done because it was a stupid mistake. Yeah? It's a bug because nobody saw it. On production, it started to behave differently. And actually, it isn't enough to just fix it. Yeah? We have to revert the whole thing, the whole feature. We have to disable it. And the ability in our software to revert whole stories, turn it on and off again, this is something critical for our peace of mind. Yeah? We can start experiment with our infrastructure. We can start experiment with the features that we have. We don't have to live in this fear that, okay, we will put it on production, and if it will break, what then? What we will do? Yeah? We will stay extra hours, we will fix it, we will be on the weekend watch, or so on. No. If it will break, we will just turn it off and fix it for as much time as we have, and then turn it on again. And then see what is happening. And everything is under our control. So the continuous delivery from a technical standpoint is the peace of mind of the team, the control of the environment that they have. Yeah? But okay, we are talking about what are the benefits and so on, but how to achieve it? Yeah? What are the steps to actually start making our big applications be continuously deliverable? Yeah? The first question that we should ask is, how big is your application? Or how big is my application? Why? Yeah? Because big applications are hard to automate, are hard to deploy. Whatever, it's always easy or easier to do it with a small application than to do it with a big application. And now, the question you should all be asking is, how do you measure? Yeah? What is the unit of application bigness? Yeah? How can we say if my application is big or my application is small? Is this the line of codes or not? Yeah? For me, the size of the application is the answer to the question, how fast are your tests? This is actually really straightforward metric that will just say you, if your tests are running more than 5 minutes, your application is big. In my definition. This is my definition. Yeah? But now there is a second question. Second question is, okay, yeah, my test should be running more than should not be running more than 5 minutes. But I have a different kind of tests. Yeah? And what is the baseline for it? Yeah? How do I know if my tests are too slow? Yeah? And this is yet my another definition. Yeah. Unit test, less than 1 millisecond. Integration tests, less than 15 milliseconds. And this is something you can just check on your CI. Yeah. Every CI or most of the CIs will tell you how big, how long are your particular tests running. And if you see that there are some tests that are running longer than this, then there is a place for improvement. Yeah. And the reason why your application is too big is because your tests are too slow, and you have to make them run faster. Yeah? And maybe your application is, after all, when you will fix it, it's a really small application, and we can go forward. But the other outcome can be that actually your application is too big, because your tests all are fine. Yeah? All your tests are meeting the requirements from the previous slide, but even then, there are so many of them because there is so much functionality that you actually cannot make your application smaller. Yeah? Then you have to split it. And everybody now knows that the most trendy thing to do is to go to microservices. Yeah, microservices with Docker and AngularJS and Redis and something else, yeah? Which is currently trendy. and this is the way you should go. Yeah? And I say yes, it's a good way to go with microservices if you have enough resources and if you have enough experience and if you know and understand all the consequences that you are going to have. What we actually picked in our company was something that we called micro applications. So what is a macro application, or what was our definition of macro applications? In microservices, basically what you are trying to achieve is to have small components with a REST API that some kind of GUI or client or some other ephemeral thing will just connect and use it. In our world, the world of web applications and mostly the portal kind of applications, we were able to slice our applications into bigger chunks, not microservices, but micro applications. So our one application was consisting of the view and the backend, but only a slice of it. So if you will go to the portal, you will actually browse the pages, and the user will see that all the pages look the same and will feel that he's on the same page all the time. But actually underneath, he is migrating or accessing a lot of different applications. No? This is, I think, more possible. This approach is possible mostly with applications that are web-based. And the first step here to achieve this is to extract your authentication and authorization logic into one service in something we called single sign-on. If you have a single sign-on and your authentication is only in authorization is only in one place, then you can safely start to divide your big monolithic application into smaller chunks and have authentication in one place, and every other application can access this one and do their job. It's the simplest solution. It's a starter point that if you will feel that, okay, we did this and it is working for us, then you can make a step forward then. Yeah? You don't have to okay, now we will be dividing and microservices and everything and all this stuff. Yeah? You can do it gradually. Yeah? And if you see that this level is enough for you, it's okay. You can stay on the level like this. And if no, you can go further. Okay. So the next thing will be something that a lot of people don't like. Yeah? Branches slows you down. In continuous delivered applications, there are no branches. Who has no branches? Hands up. Who is? Oh, one person, I think. Yes, on the right. Somebody else on the other side. Okay, so we have two people. Two people with no. Sorry. Two people with no branches. Yeah. Why do we? Or question to the audience. Why do you use branches? What do they solve for you? What is the reason why you are branching?
Code reviews.
Code reviews. Great example. What else? No, everybody is doing it, yeah? So we have to know why we are doing it. What is the benefit of it?
Work in progress.
Work in progress. Parallelizing the work. Yeah, we don't want to break each other's code. We want to parallelize our work. Great. Something else?
Isolate the changes.
Sorry, one second.
Isolate the changes.
Yes, isolate the changes so that two versions of code do not impact each other, so that we can safely have one and have the second and deploy them separately and have them. Yeah? And, sorry? Experiments. Yeah? Sometimes we don't know if something we should enable on production, put it on production or not. We want to just experiment something else. Can be. But this is, I think that this we can put under experiment maybe or something like this. That actually parallelization of the work will be the generalization of a couple of things that you said. Yeah? That we want to be able to simultaneously two or more people working on the same feature or on the same part of the application. And now the question, are the branches the only way to do it? Because this is what we were taught. Yeah? That if you want to parallelize your work, you need to have branches. And then, of course, you need to merge. And everybody knows that merges are great, simple, pleasure to work with every time. No conflicts, nothing at all. Everything just works after you merge. Yeah, that's a common knowledge. The other thing we can do to achieve all the goals that you set is something that I call feature switches or incremental changes. Some changes are so small or so trivial that they actually do not require any branch, yeah? Because making a branch would be more work than to actually implement the feature. Yeah? For example, change the color of the button on the page from yellow to green. Yeah? One CSS changed. Yeah? I don't need to have a branch for it. Yeah? Or something else that is trivial. Yeah? But all of the other thing, the parallelization, I can do within my application. I actually can start thinking about my features and keeping them within my applications, two different features on two different versions of the same module or of the same class within my app, within a trunk. Yeah? But then I need something, some configuration, some if, some condition that I can enable or disable depending on if the feature is on or off, if I want to enable it or to disable it. Yeah? But then we can say, okay, so what are you saying? That we should like put conditionals everywhere in our code? Yes. And no. When you start to embrace this approach that you stop doing branches, then you have to start thinking about your application, your code, and your architecture in a little bit different way. Yeah? You have to enable your application to be able to run two versions of the same code in parallel. So your application needs to working with the version A and with version B. Yeah? And ideally, you want to, like with this magical dashboard, you want to click, and your product owner should be able to click and run it 1 and 2, and 1 and 2. Yeah? What this enables you, or forces you to do, is to stop just making a branch and then rambling through your code, not thinking about what should be the architecture of this stuff, but just, now I will re-implement this implementation of the interface, and now I will do it so that it works. In this approach, it's not that easy. In this approach, first, you need to start branching by abstraction. So since you have to maintain two versions of the features, because you want to be able to throw them, enable them conditionally, you have to be able to have two of them. You have to find this abstraction. You have to first refactor your code. Yeah? This approach guides you to seeing where are those different implementations, where does your code changes, yeah? Where you should put new interfaces, where you should modularize. You cannot just bypass it. You have to embrace it. Yeah? And it will impact your application architecture greatly. Yeah? Because your team and you will be forced to think about how are you introducing changes and how your architecture is accepting those changes, and how you have to change it to be able to have those common abstractions for two different ways of doing one thing, and then exchanging the implementation in the runtime on production. The next thing is write your tests and make them fast. Yeah, obvious. Everybody writes tests. Everybody writes fast tests. Yeah, maybe everybody, but my experience is that when I come to any company, most of the problems that they have is that, okay, our tests are slow, our tests are hard to maintain, our tests are breaking, we don't know for what reason, and writing them is really pain in the ass. Yeah? So actually, I think it is a really important thing to say. But approach to testing in this kind of environment needs to be a little, let's say, smart. Yeah? And to go to it, we need to, again, make some vocabulary. And this vocabulary is that there are only two kinds of bugs in the system. I want you to think for a second that there are only two kinds of bugs in the system. The one that forbids user to complete an action. Yeah? You have a, I don't know, payment system, user clicks, he wants to pay, and he gets an error page. Sorry, we could not process your payment. Maybe in the future. Yeah? And the second kind of error is user can complete the action wrong. You actually allow the user with wrong data to be able to perform some action and have a wrong results. And these are the problematic bugs. Because the other ones, okay, user just cannot do it. If we have continuous integration system, and we can react very quickly, because it takes us commit and then let's say 15 minutes to deploy to production, then those first bugs are not a really big problem, because they are not making a data inconsistent. They are just making the user irritated. But if we can react within 15 minutes to it, they are not really the bugs that are worth testing for or hunting for. We can allow to have some amount of them. But the other ones are the ones that we have to be prepared for. Yeah? You cannot make your test, you cannot have 100% test coverage. Yeah? In your application, in your architecture that you have, there are two kinds of code. Important one, the domain code, the domain logic, that is responsible for the important stuff that you are doing, yeah? And the stuff that is all around you. I borrowed this from a book, very good book, Growing Object-Oriented Code Guided by Tests. Very good book, but not price. By not price, and the second guy I don't remember. And here, they are having this architecture. This architecture of the application, it has a lot of different names. Clean architecture, hexagonal architecture, onion architecture, and once I've also heard Life Preserver, the newest version, Life Preserver, because it looks a little bit like Life Preserver. And what this application, architecture of the application consists of, it makes a really big distinction between your domain code and your integration code. Where the domain code is the code that is important for you, yeah? That actually makes some money. Yeah? It's doing this super fancy algorithms that you all have, yeah? for making money. And the code all around it is the code that is doing integrations. It's presenting your data through, I don't know, REST API. It's persisting the data to your application. It's connecting to some other services and modules via something else, I don't know, yeah? Corba. And on the other hand, it has some, I don't know, views in web and so on. Yeah? And if we will go to the previous slide, those two kinds of errors we can safely map to this particular architecture or this particular approach. The first ones, the ones that we are that are just forbidding the user from completing the action, mostly live here. Mostly live in the integration parts, because there is some problem with parsing, with data transformation, with some kind of validation at the structure level, or other stupid stuff that the framework we didn't knew what it was actually doing, and it was doing something else that we expected, and so on. And this code, which we have right here, the domain code, this is the code that is responsible for the second kind of errors, for the user can complete the action wrong. Yeah? If our business rules are wrong or our domain code is wrong, then we have a problem. So if we have the continuous, if you have the continuous delivery approach, and we want to be safe and consciously deploy the good quality of code to production, we first need to focus on the core logic and make it bulletproof. And if we have time and resources, we can do other testing. And in most cases, if you are not doing some, I don't know, life-saving software or rocket or military or some really strict finance thing, you can go this way. Yeah? If your interface breaks, nothing really happens if you can fix it quickly. Yeah? If you don't have continuous delivery and you have to wait for a fix for about, I don't know, 1 week or even 1 day, it is a problem. You have to be prepared. You have to have a big test coverage. But if you have a continuous delivery approach, you don't have to. You can live without it, and you can act on it when it comes. Yeah? Okay, you should be like doing everything the best you can, of course. Yeah? But errors always happen. Yeah? And we have to prioritize. We need to have an application architecture that can tell us what is important and what is not. The next thing you have to do is make your application configurable. One of the configurations will be telling the application which features are on and off. And in a perfect world, we, for example, had a microservice that had its own, or micro application that had its own view with this dashboard, and we could turn off and on the application on different stages. Yeah? There was just a matrix 2x2, stages, features, and product owner could click on and on. Yeah? In this kind of approach with configurable application, you have one binary, and your test stage is not defined by the machine on which the particular application is deployed. It's defined by the configuration that you put to your application. So you can work on a feature, enable it on a test, and not enable it on production. And then your testers can have as much time as they need for testing it, if you require some kind of manual testing or anything else. But if and it can go on. Yeah, you don't have to like think about it. Yeah, it doesn't block you. If they need more time, they have more time, and you can work on some other features and put them in the meantime. Yeah, the code that goes daily, and just the configuration describes what actually is visible for particular kind of users. The next thing is monitoring. If you in continuous delivery, you don't have much time for doing all the stuff that we usually do by hand. So metrics or checking the code quality and so on. Everything needs to be automated. Yeah? So if you deploy your application to production and there is some kind of error, you cannot wait for the user to call you and say, hey, there is an error. You need to have infrastructure in place that will tell you that, hey, what you just deployed actually broke something. And you need to react, yeah? And you need to turn off the feature, roll back to your previous application. Yeah? Everything needs to be automated. It cannot be like I have to think about it, that now I'm doing commit, and if something breaks, now I have to wait and try and see and click the application on production. No. If something will break, I will receive a notification from my monitoring, which is set up in a way that I can trust it. And we do this setup once, and we mostly forget about it. Yeah? How you want to do is, it's a different kind of code. So first, the static code analysis. Yeah? A lot of quality within your code can be done by some kind of sonar or other plugins that you can put into your build chain and just check for the obvious things. So that the code review process and other stuff that we were mentioning that branches are good for can focus on like actual value and not checking if the catch block is not empty, yeah? Or if the formatting is okay. The process and application metrics. The process metrics are the metrics of your business, yeah? That are saying that our application currently always have 100 users on a page, and after our last release or our last deployment, it has only 10 users on the page. What happened? Yeah? Or our business flow that we had always generates, I don't know, 10 sales per hour, and after our last release, we have just 1 sale per hour. What is broken on a business level? And the third thing is application monitoring, so like memory, CPU, thread pools, and all of the other stuff that is important. And the last thing that enables you to go in this direction is your infrastructure needs to enable you. So creating a new application and setting up a new server, new thing needs to be easy. Yeah? It can be hard because people will not do it. If it requires like 2 days of work and asking external team of provisioning you a machine and so on, you will not create additional machine. You would prefer to make your current code base bigger than to extract it to a separate thing, unless it will be just that simple to add yet another thing to your app. And this is where like all of the virtualization and containerization comes in. Yeah? Pick your technology, any technology, yeah? Whatever you want. Anything can work for you. It doesn't have to be Docker. It's not production ready yet. So in summary, when you decide to go to the continuous delivery part, it will enable or it will make you change in this particular area, culture and organization. I remember that first time that we said, okay, now we will not do branches. We will just be doing feature switches within code. Half of the people in the company, programmers, said, no, are you stupid? You want us to like put ifs in the code? Everybody knows that you should not put ifs in the code. And after around 3-4 months, the same people that were shouting the loudest were convincing the new people that were coming to the team that this is how we do stuff. This is a good way of doing things. Yeah? It makes some time to get used to it, but after a time you can see, when you will see those benefits or you will experience the benefits, you will know that it was worth it. Design and architecture. Yeah? You will have to rethink of how you are architecting and designing your components. What are the important parts and what are the non-important parts, and where do they live? And does everybody know where do they live? Build and deploy, yeah, it just needs to be, it needs to enable you to create small application. Test and verification, you have to know which parts are worth testing and which are not, because you will not have enough time to test everything, and that everything needs to be tested well. And the last is information and reporting. Yeah? All the metrics, all the stuff, you need to have it. Yeah? Unless you don't have unless you are not aware of all of those things, then you want to go to continuous delivery path, then you will go into the trap, or something will backfire on you because you will not be prepared. Okay, so that was actually all I wanted to tell you. Thank you very much for your patience, and if you have some questions, you're welcome.
Yeah, I have a question about like features toggles. Mm-hmm. Do you delete those toggles once it's like enabled for good, or you leave it there?
It actually depends. Our product owner are responsible for telling us which should be deleted and which should not be deleted, because some of them, for whatever reason, they want to keep, because they feel safe that if there is a very important feature, that anytime they want to, they can disable it for some reason. But most of them, if they are small, then we are deleting them. Yeah? Once every I don't know, month, there is one technical story, we called it, which lists all of these feature switches that do not have to be there anymore, and we just remove them, delete them.
Yeah, so the reason I ask is like because if you have like 10 feature switches, mm-hmm. like how many times you test your application? Once with all features turned on, or like 2 to the power of 10 times, because you have like that many combinations of your like application actually?
We are not testing the application, we are testing features.
Okay.
So we are not doing a lot of the big tests that we test the whole application with integration tests. We have a big test coverage on the core domain, which are mostly unit tests and integration tests, but only integration tests of our components. And we test each component separately. So each feature, each implementation has its own set of tests. And these are tested. And if you remove the feature, you remove the tests for it and remove the code for it. And we do not have any combinational tests that test all of the stuff, because it would be too big. We just assume that if our core domain is tested in a way that user cannot do any malicious thing with it. So if we have some errors in the view, or something is for some reason for a couple of minutes broken, we accept it. Yeah, it makes us faster because we can deliver faster and react on the small things in the user interface when it breaks, but we can do it fast, so we don't really care.